All right. So like I said earlier, this is the last section of the chapter. It's section 3.5, and it's called Equations of a Line. And I also mentioned that you probably did this in Algebra 1, but I'm not coming into this class saying, oh, you guys already know this from Algebra 1, so here's the problems, do them. I'm not going to do that, okay? I'm teaching this as if it was basically an Algebra 1 lesson, and you'd never seen this stuff before, all right? So you can't say, well, you keep saying, because I had somebody say something to me. I forget who, when it was, but they said, you keep saying we're supposed to learn this stuff before, but I never learned this before, okay? And I get that. Some of you have not learned this before. So everybody pay attention, face the front, turn all the way in your seat. Thank you. So it doesn't look like I'm going to be able to put the two of you next to each other. Is that right? Huh? Rosa? I don't know. It seems like you've always turned around and looking and talking with her, so maybe I'll have to move you. Is that right? Okay. Yeah, well, sit forward then. Okay, enough of that. So here we go. Let's talk about that. So we've talked about points, how to plot a point, and all that kind of thing. All right. So for instance, I'll tell you what. Let's do this before. Let's grab one of these. All right. You've seen this thing before, right? And all right. So what if let's do this in this pink color. What if I gave you some points like -3, 2, and 4, 5? Just put this in your notes, okay? Just do a little X and Y axis. You don't have to have all the grid marks and stuff on there, but just do a little X and Y axis. So plot these 2 points on an X and Y axis. You don't need to have all these grid marks. So it should look like this. -3, 2, you start at the origin. You go 1, 2, 3, 1, 2, right there. Okay, that should be the 1 point. And then 4, 5. So you start at the origin. You go 4 to the right. 1, 2, 3, 4, and 5 up. 1, 2, 3, 4, 5, right there. Okay. No, so those are 2 points that we can plot. But if I connect those 2 points, what do I get? I get a line, exactly. All right, so I'm going to extend it like this. I'm not going to start and stop at the line. I'm going to go all the way through it, because what does a line do? A line keeps what? Keeps going. It is infinite, correct. So that would be a line that connects those 2 points. So any 2 points. Can I just have 1 point and have a specific line that goes through that 1 point? I could, but is it one unique point though? Or I'm sorry, is it one unique line? No, it's not. I could have, how many lines could I have going through that one particular point right there? I could have an infinite. Very good. That's the answer I was looking for. I could have an infinite number of lines going through that point. Would you agree? I mean, I could sit here all day, right, and do this and make lots and lots of lines that go through that point. What about the 2 points, though? If I gave you this point and this point right here, we'll call this point A, we'll call this point B. So this is A, and this is B. How many unique lines could I draw through those 2 points? Through those 2 points, I can draw an infinite number of lines. Just one. That's it. I can only have one. Do you agree? Now, that's just kind of starting us off on what we're going to do. I just want you to understand that this represents 2 points represent a line. Now, I could put another point in here and it still be on the line. For instance, maybe right there. That would be a point on a line, wouldn't it? How many points are actually on this line right here? A lot? An infinite number of points. Right. We've been using that for an answer a couple times already today. But I could have all kinds of points on here, couldn't I? I could just keep drawing points on this line. They don't even have to go right through the grid marks, okay? I could have 1,000,000 points on this line, or I could have 1,000,000,000, or I could have 1,000,000,000,000. But really, how many do I have? I have an infinite number of points. What's the least number of points in order to make a line? 2, right. That's the least number of points to make up a line. Everybody with me on that? That's really important. Now, this line, you can name the line. Now we could call it like line L, or I could call it line AB. But what we have is this thing right here, an equation of a line. We can actually name it with an equation. There's actually two equations we're going to deal with today. Okay, the first equation is an equation that we put in standard form. I'll show you what that is in a minute here, but let me just write down the names of them. Okay, so we have an equation of a line that's written in standard form. It's probably not the best one as far as practicality to use, but it just looks nice and pretty. Okay, people use it a lot, and we will use it. All right, that's standard form. The second one is a little bit more practical, and it's one that we're going to use quite a bit. Okay, and it's called the slope-intercept form. You guys remember this from Algebra 1 at all? Yeah. And again, I'm not working on the assumption that you already know it. I'm just going to keep going. Okay, I'm going to teach it to you just like I taught it for the first time. Okay, it's called the slope-intercept form. But there's two ways to describe this line, right? There's actually other ways too, but today there's just two ways that we're going to talk about that describe this line right here. And it tells you some stuff. It'll tell you some information to tell you exactly what that line looks like, okay? What slope it is, right? What points it goes through and all that kind of stuff. So let's first of all talk about the standard form of a line. All right, let's push that up there. Let's change colors. All right, so let's do the standard form. Oops, thought I was changing colors. Why did it change? Let's try it. There we go. All right, so let's do the standard form. I'll just write it out for you, and then we're going to talk about it a little bit. All right, so the standard form is this. It's AX plus BY equals C. All right, that's the standard form of an equation of a line. Like, I don't know what any of that stuff means. I know. I get it. We're going to talk about it here in a second, though. And I'll tell you what. I still have that copied. I'm just going to push this over for right now. We're going to use this in a minute. If I can grab it. Where is it? What's going on? There it goes. Okay. So what does this mean? What does the A represent? What does the B represent? What does the C represent? Well, you can't just look at the A, B, and C and say, oh, I put a point right here and I put a point right here and I'm going to get a line. You can't really do that. What we're going to do are things called intercepts. We're going to have an x-intercept and we're going to have a y-intercept. And I'm going to show you how all this fits together here in just a second. Okay. So when it says intercept, now we know what the x-axis is. It's this horizontal one right there. Would you agree? Yeah? We've talked about that before, right? We had a whole thing on the axes and all that kind of stuff. And which was the y-axis? That one going up and down is the y-axis. So the x-intercept means where your line crosses the x-axis. Let's just kind of flip up to the top right here. Look at that line AB. Now, it may not cross exactly at one of these grid marks, but where does it cross the x-axis? It crosses right here. I'll just circle it. Do you see that? See that line AB? And where does it cross the x-axis? It crosses right here. Okay, where does it cross the y-axis? It crosses right there. Everybody see that? This is the x-intercept. I'll just shorten it and just put INT. Okay, that's the x-intercept, and this one right there is the y-intercept. All right. So visually, that's what's going on. So I want you to understand what, because I'm going to show you how to find the x-intercept, and I'm going to show you how to find the y-intercept. But I want you to know visually what you're finding. When I say find the x-intercept, I want you to understand what you're actually finding. You're finding out where that line crosses the x-axis. If I ask you to find the y-intercept, I need you to understand and visualize that you're finding where that line crosses the y-intercept or the y-axis. If I get my words straight here. Okay, so the y-intercept is where the line crosses the y-axis. Okay, so that's what you're trying to find here. So I'm going to go right to the example. This is example 1. Since this is the first time we've done this lesson, we start off with example 1. I'm going to give you an equation in standard form, and we're going to graph that equation. All right, so here's the equation. It's 2x minus 3y, and it equals negative 6. So what we can do is they can give you an equation, and what we're going to do is take that equation and actually graph it on our little graph right here, okay? And we got to know how to do that. Now, right now, you may not have any clue at all. Oops, let's get rid of that x and y stuff before I move that thing around. All right, let's move it about right there. Will be a good spot for it. So what I'm going to do is I'm going to find the x-intercept and I'm going to find the y-intercept. Now watch very carefully. In order to find the x-intercept, now I'm not really sure. I actually don't really know where this crosses the x-axis off the top of my head, okay, just by looking at it. I'm going to have to do a little work. But let's just say it crosses right there. What would this point, that point that I just drew right there, and again, it may not correspond to this equation at all. I'm just kind of giving you some background information. This point right there, what is that point? You start here and it's what? 1, 2, 3, 4. So how would I write the ordered pair for that point right there? It's negative 4, comma what? 0, okay? Now notice something. This, if I had a line and it crossed the x-axis through that point right there, okay, that would be my x-intercept, wouldn't it? It's where the line would cross the x-axis. Now tell me something about the y part of this. It's 0, isn't it? Okay? So watch what I'm doing here. In order to find the x-intercept, like anywhere, like if I did an x-intercept right here, well, what is that point right there? It's 2, what? 0. Not O. O is a letter. Okay, 0 is a number. What if I did a point right here? Somebody tell me what that is. That's 2, 3, 4, 5, 6, 7. So what would this point be? 7, 0. Tell me something about every single point on the x that crosses the x-axis. What's true about it? The y is always going to be 0. Very good. Okay, the y is always going to be 0. Does this make sense so far? So what we're going to do, in order to find the x-intercept, what we're going to do, we're going to set y equal to 0. Does that make sense? Because every time it crosses the y-axis, the y is 0. So if I want to find out where the x-intercept is, I'm going to set y equal to 0 because every single one of these, whatever this one was, negative, that's probably negative 7, 0. Okay, every single one of these, the y was equal to 0, and that would be the x-intercept. Okay? Now, conversely, what do you think you're going to do here? In order to find the y-intercept, what do you think you're going to do? You're going to set, look, to find the x-intercept, you set y equal to 0. Follow along. It's not that hard. To find the y-intercept, you set what? X equal to 0. Okay? Everybody see that? Tell you what, let me get all those dots and things out of the way. Erase it. There we go. All right, this is super important, what we're doing right here. In order to graph an equation in standard form, what we're going to do is we're going to find the x-intercept, we're going to find the y-intercept. How do you find them? You set, to find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0. So what we're going to do, eventually, we're going to get a point on the x-axis, and we're going to get a point on the y-axis. How many points does it take to make a line? 2. So I'm going to get a point on the x-axis, a point on the y-axis, and then I just connect the 2 points, and I've got my graph. And then you would have graphed this equation right here. So that's what we're going to do. So let's do the let's do the x-intercept first. Okay, so find the x-intercept. So if I find the x-intercept, what do? I set what? Y equal to 0. What does that mean? Well, I'm taking this equation right here, this thing that they gave us. Okay, that's what they gave us. So what am I gonna replace here? I'm gonna replace wherever there's a y. What am I gonna put in its place? I'm gonna put in a 0. Okay, and then what could I solve for? If I make this a 0, then what could I solve for? What's the only variable in here? If this is a 0, I could solve for x, and that would be my x-intercept. Okay. So that would be one of my 2 points. Remember, I got to find 2 points. This would be one of them. Okay? So let's do it. Let's put a 0 in for y. So we're going to take this formula. So watch. 2x minus 3 times y. What did I say I'm going to make my y? Make it a 0. And that equals negative 6. So all I did was rewrite this equation. I just stuck in a 0 in for the y. That's all I did. Let's see what we get. And making that a 0 makes this kind of easy. So 2x, I didn't do anything to that. Minus 3 times 0. What's 3 times 0? It's just 0. So I don't even need it now, do I? It just goes away. Equals what? Negative 6. And now I do a quick little algebra, super easy algebra. How do I get x by itself now? Divide by 2. Right, divide both sides by 2. And what's my x equal to? Well, not 3. It's negative 3. Okay, I'm just going to write negative 3. What did I just find right there? I just found the x-intercept. I found where my line is going to cross the x-axis. That's what I wanted to find all along, isn't it? But I also need to find out where it crosses the what? The y-axis. We'll do that in just a second, okay? But let's put the point here. So x is negative 3. So I come over 1, 2, 3. I don't go up or down because remember my y is 0. So my x-intercept is technically negative 3, 0. Doesn't that look like an x-intercept? Remember I put all those dots on here earlier and every one of them had a 0 for the y? That's what we have here. So that's my x-intercept. But I got to have another point. I can't just have one point because how many lines could I have going through that point? I could have an infinite number of lines, couldn't I? So I need another point. And I'm going to get it right here. Let's do that in a different color just so it... We're going to do kind of the same thing, except this time, instead of setting y equal to 0, what are we going to set? We're going to set x equal to 0. So now I'm going to find the y-intercept. In order to find the y-intercept, I set the other one, which is x. I set that equal to 0. Everybody got it? See if you can do it. Go ahead. I'll give you like 15 seconds. Set x equal to 0. Just do it. Just put in a 0 for x. Come on. You should be able to do it in your head. Everybody try it. Don't worry about the time. Just try it. Just try it. Forget that I said 15 seconds. Just try it. So you're going to take this equation right here. You're going to set equal to 0, and then you're going to try to find what y is equal to. Some of you guys probably already have it. Did everybody try it? See a lot of people just sitting there, not even budging. Didn't even try it. Don't know what to tell you. All right? If you can't even sit there, pick up a pencil, and just write this down, I don't know what to tell you. But most of you are. All right, so what do we do? I gave you more than 15 seconds. We set x equal to 0. So what do we do here? We put 2 times what? Not 2x, 2 times 0. Right. And then we just write the rest of it out. Minus 3y equals negative 6. You see, all I did was rewrite this equation. That's all I did. Except instead of putting an x here, what did I put? I put a 0 in for the x. That's all I did. 2 times 0 is 0, so that just goes away, right? And then I've got negative 3y equals negative 6. Quick little algebra. Get y by itself. Divide by negative 3. That cancels out. Y equals what? Negative 6 divided by negative 3. What's that? Positive 2. So what is my y-intercept? It's 0. Very good. 0 what? 2. And so why did I find that? Because I needed a second point, right, to make my line. So what I'm going to do is plot that point, 0, 2. So I go 0 on the x and 2 on the y. Put a point right there. Now what do I do with those 2 points? I make a line. That's right. I just connect them. I just connect them and make a line. That's all I do. So watch. Oops. Let's try this. All right. So extend it out. Don't just go from point to point, though. Okay. Extend it out because remember, a line we said earlier is infinite, right? So, whoops. There we go. That looks a little bit better. And it is a line, so we put arrows. Oops. There goes my marker. Let's try this again. There we go. So we put arrows. So what did we just do right there? And I didn't even put what this question said to do. It says to graph. Okay? It says to graph this equation. And we did that by using x-intercepts and y-intercepts. And that's what it would look like. This is the answer right here. This graph, this line right here, going through these 2 points, that's your answer. So what am I checking? I'm not just checking that you put any old line there. I'm looking that it goes through -3, 0. I'm looking for that point, and it goes through 0, 2. I'm looking for that point, and I'm looking that you drew the line through those 2 points. Once you do that, that's your line. So you just graphed your first line, right? At least in geometry. You probably did this in Algebra 1. Anybody recall doing this in Algebra 1? Nobody? You do? Got one person that took that 3, 4, 5 now, 6. Okay, now some of you are saying it. Yeah. But listen. Guys, let's not worry about it. Yeah, why does that matter? Why does it matter? Nadir, don't worry about it. Okay, just all I'm trying to do is get an idea if you guys are familiar with this. Even if, Trevor, it's enough. Stop. I'm sorry I asked. Oh my gosh, I didn't think it would cause an issue. I asked a simple little question. Nadir, you started that whole thing, okay? Don't worry about it. So, that's how you graph an equation of, or that's how you graph a line given it in standard form. This is in standard form right here. Okay, yeah, Gigi. Yeah. So, in this case right here, what was the A in this situation? Here's my graph. See, it's in the blue box right there. What was the A? The 2. Right, that is your A. What was the B? It's not just a 3. It's a -3. See, it's a -3. Okay? And what was the C? -6. Okay? So when you see it in standard form, a very easy way to graph an equation in standard form is to use the x and y intercepts. Okay? So if I ask you to graph something and it looks something like this in standard form, you need to find the x-intercept and then plot the point, find the y-intercept, plot the point, connect the 2 points, boom, you're done. Okay? But I said that there was 2 types of lines. Well, there's more, but today, at least in here, we're only going to talk about 2 of them. The first one was the standard form. What was the second form? What was it? Slope-intercept form. Very good. So let's write that down and let's talk about that. So we're just going to do the 2 today. So we did standard form. Now what we're going to do is slope-intercept form. This one I said earlier, it's a lot more practical. All right? I can just look at this equation and I can tell a couple things about it. All right? Whereas the standard form, I couldn't. Knowing that the A was 2 and the B was -3 and the C was -6, I really just couldn't look at that and say, oh, that's what my graph looks like. But this one coming up right here, the slope-intercept form, I can just look at it and I can tell you what it's going to look like. I can tell you where it crosses an axis. I could tell you the slope of it, right? How steep it is, whether it's positive or negative. I can just look at it and tell. Okay, and that's what's really nice about the slope-intercept form. So let me just look at the example. I'll tell you what, I'm going to do an example before I do their example. So we'll call this example 1A, all right, or whatever. It doesn't matter what you call it. So I'm going to show you what the slope-intercept form is, and it's this. It's y equals mx plus b. Now, you know what a couple of these things are. The x and the y represent a point on the line, okay? Everybody knows that, right? Ordered pair, x, y. So that x and that y represent a point on the line. You know this one. We just had, oops, there goes my pen. Yeah, you know what that means. That's the slope. Now, you actually know what this means, but you don't know it by the letter b. Now, you may remember it from last year in Algebra 1. Does anybody remember what the b stood for on the equation of a line? Do you guys remember doing y equals mx plus b last year, though? Okay. So the b represents the y-intercept. So we just learned what the y-intercept was, but the b, that number right there, is the y-intercept. Now visually, what is that doing? You got a line, you got an x and a y thing. What does the y-intercept tell you it's doing? Now just think of the y-intercept, just the y-intercept. Visually, you're looking at a graph, you're looking at a line that goes through the graph. What is the y-intercept? It's where your line crosses or intersects, you could say intersects, right, where it crosses or intersects the y-axis. Very good, okay? So that's what that is right there. You know what the slope is, right? It's how steep it is, right? It could be flat, it could be really steep, it could be going to the left, it could be going to the right. That's what the slope means. So if I gave you, oops, there it goes again, third time today. I got to quit clicking on this button on this pen. It keeps doing that. They do be cooking. All right. So what if I gave you something like this and I asked you to graph it? Okay. I could tell you something right away. I could tell you two things right away. First thing is this one. What is that? That's the what of your graph? That's your y what? Intercept. So that's where your line's going to cross the x-axis. So let's put this graph thing up here again. Watch how easy it is to graph this. I promise. This really is not difficult at all. It's actually pretty easy. If you understand what these two numbers represent, this represents the y-intercept. So right now, remember how many points does it take to make a line? 2. That's the least number of points to make a line, okay? So it basically gives you, it gives you the 2 points. At least it gives you the 1 right here. So it tells the y-intercept. What does that mean? It means that where this line crosses the y-axis. It crosses where? Where does it cross the y-axis? At -5. So what are we going to do? Let's go on the y-axis, find where -5 is, and put a dot there. Okay, put a point. So here's the origin. We go on the y-axis, down 5. 1, 2, 3, 4, 5. And we put a point right there. So I know my line is actually going to go through that point right there. Now, how do I know how it slants? Well, I don't know. It could slant like this. It could slant like this. It could be really steep. It could be kind of flat. I'm not really sure. But what's going to tell us how it slants? The slope. That's right. So this right there is your slope. That's going to tell you how it slants. You remember what the slope is? It's rise over run. Everybody remember that, right? We had a quiz on that. It'll be on the test. Okay, rise. Now, let's put this number in here. So I want to rise and I want to run. So how do I write 2 with a rise and a run? It would be 2 over what? What is it? 1. Okay, I think I heard a 1 out there. So it'd be 2 over 1. Everybody see that? And they told us that in the equation, okay? They flat out said, here's your slope, here's your y-intercept, just graph the thing, all right? Like, okay, I can do that. The y-intercept's the first thing I'm going to do. I'm going to put the point where the y-intercept is. And now, from that y-intercept, don't go back to the origin, but stay at the y-intercept. Let's do the slope from that point. So what do? I rise and I run. How far do I rise? 2, 1, 2. And how far do I run? 1. To the what? Left or right? To the right. And I put a dot right there. And guess what? I got 2 dots. I got 2 points. Can I make a line if I got 2 points? Absolutely. If I wanted to. See how close together these are? Sometimes I'll do this. So I rose 2 and I ran once, right? You could do it again. Watch. Start from here, rise 2, run 1. Did they still lie? Did they still form the same line? Absolutely. If I wanted to do it again, I could. 1, 2, 1. Everybody see that? All right, just to kind of make sure, because these were kind of close together, sometimes I like to do that. So what you can do now is just connect, and they should all connect if you have a nice graph. That's pretty close. All right, and put arrows because it is a line, and that's your line. This line right here, this pink line right here, is y equals 2x minus 5. What does it tell you? It tells you the y-intercept, and it tells you the what? The slope, how steep it is. Okay, you rise 2, you run 1. And then you've got your line. It's as easy as that. I want you to try this one on your own. I'm making things up here, okay, as we go. I'll give you one that's a little bit harder. We got one more example to do. It's a little bit tougher, but this one you should be able to do. So what if I asked you, and this will be on the test, I will ask you to do something like this, okay? I will ask you to graph y equals, I'm going to make it a little bit trickier for you, 2/3 x plus 1, okay? What I want you to do is I want you to graph this. I know you don't have fancy graph paper like I do, I mean, you might have it with you, but you don't need it. Just draw your x and y axis. And the first thing we're going to do is what to this equation right here? What's the first thing that we're going to plot? There's a point. You can just look at it. It's the y. Right, the y-intercept. Exactly right. We'll keep this pink. All right? So everybody's looking at this, right? Y equals negative 2/3 x. Forget the negative 2/3. It looks like it's going to be really hard, but it's really not. Okay? The easiest part of this is doing the y-intercept. So it's the thing that's on the end. It's that plus b. So what do I do with that 1? Where do I put 1? Well, I go on the y-axis. It's the y-intercept, so I go on the y-axis right there, that up and down one, and I just put a dot right there at 1. Everybody can do that, right? Yes? Everybody should be able to do that. There was no math involved. All I do is I look at that point. I'm like, oh, that means I put a 1, put a dot or a point, okay, at 1 on the y-axis. This is your y-axis. Now, what do I do with this thing? It looks weird because it's a fraction. It's really not that bad. Go ahead, Nathan.
So you go down to...
Yeah, where do I start, though?
You start at the y-intercept.
Yeah, you start at the y-intercept. Very good. Okay, everybody watching? Go ahead, Nathan, talk me through it.
So you start the y-intercept and you go down 2.
Go down 2.
And then go to the right 3.
1, 2, 3. Exactly right. Because it's rise over run. Because it's negative 2 over 3, which is rise over run. Now watch this. Doesn't matter if the negative is on top or the negative is on the bottom. It's still a negative fraction, right? Very good. But watch this. Let's start here, and let's do rise over run now with this thing right here. So I start here. What's my rise? 2, 1, 2. And what's my run? Negative 3. So which direction am I going to go? I'm going to go to the left. 1, 2, 3. Look at that. It's still part of that same straight line, isn't it? All right. So it doesn't matter if this is negative. It doesn't matter if you put the negative on top or the negative on the bottom. All right. Now, what do I do once I get my points? Just connect them, right? And then I like to extend it a little bit. Okay. Don't just go from one point to the other and stop it. Okay. Make sure you go beyond the points and then put arrows on the ends because it is a line. And there it is. The question was for you to graph it. And there's your graph right there. That pink line right there, that's your graph. What do you think? That's pretty easy, isn't it? All right. Let me show you one more thing. You got it in you? You guys have been doing pretty good today. All right. So let's do one more, and then we'll stop. So this is actually example 2. Yeah, let's do this one. So example 2. 3x plus 4y equals negative 4. Now, the problem says this. If you look in the book, it says, write this in slope-intercept form and then graph it, okay, using slope and y-intercept. So this kind of looks like standard form. It looks like we would do that x and y-intercept thing, right? Doesn't it look like that first problem that we did today? Yeah. But the problem specifically says, let's write this in slope-intercept form. Well, what is slope-intercept form again? It's y equals what? mx plus b. All right, that should just roll off your tongue after you do this a while, okay? Y equals mx plus b. It's a very, very, very common formula or equation, should say, in algebra, in math, all right? So what does that mean? This doesn't look like it's y equals mx plus b. So what should we do to it to make it look like y equals mx plus b? We should be able to solve for what? Solve for what? Solve for y. That's right. Because look, y is by itself here. So what we're going to do is we're going to try to get this y right here by itself. Okay. So let me do this. Let me rewrite it, and we're going to do the algebra. This part right here is just straight up algebra. Trent, what do you think you're going to do first? We want this to stay over here, right? So what do we want to get rid of? The 3x. Let's get rid of the 3x first, okay? So I want to move the x over to the other side. Because remember, look, x is on the other side here, isn't it? So I don't want it over here with the y. I want to move it to the other side. How do I do that? How do I move that 3x over? You subtract it. Exactly right. You subtract it from both sides. So I subtract it from this side. I subtract it from this side. Let's see what we get after we subtract it. This cancels out. We're left with a 4y. Now, we write this, y equals mx plus b. So the x I want to go first, okay? I don't want to go negative 4 minus 3x. I want to go negative 3x minus 4. And we're almost done changing it into slope-intercept form. We're almost done. One more step. Remember, what are we trying to do? We're trying to get y by itself, aren't we? So I got to get rid of that 4. How do I get rid of the 4, Candace? I divide both sides by 4. Now watch very carefully. Everybody watch. Don't just divide this by 4. Don't just divide this by 4. You're going to have to divide what? Both of them by 4. Okay, whatever you do to one side, you got to do to the whole entire other side. All right, so I divided this by 4 and then divided this by 4. Yep.
Could you also divide the whole thing by 4?
Yeah, but I like it like this because I want like two separate things here. But you could put just one line and put it over 4. But I like it like this because a lot of people will forget about dividing one of the other ones. Okay, so I do it twice. So what's this going to be? This is going to be negative 3/4 x. What's this going to come out to be? What's 4 over 4? It's just a 1. So look what we just did. We just changed it from standard form into slope-intercept form. Okay, and they want you to graph it now. Okay, so part of their instructions was to change it to slope-intercept form. That's part of this problem. We just did that. And now we should be able to graph it. And now graphing it, that's the easy part. What we just did right there was definitely a little bit more work. All right, so let's graph this thing. Should be pretty easy to graph now. What's the first thing we look at? Here's what we're graphing. This thing right there. The y-intercept, that's right. So what is the y-intercept here? Come on, everybody look up here. What's the y-intercept in this equation? It's negative 1. Everybody should be able to just look at it and tell. There's no math involved at this point. Okay, we already did all the math. That's your y-intercept. So what do we do with the y-intercept? You go on the y-axis and you put a point at negative 1. So you just put a point right there. What's the second thing we have to do before we connect the 2 points? Find the slope, the rise over run. Okay, so rise over run is what? It's negative 3 over 4. So we start at the y-intercept, we rise negative 3, 1, 2, 3, and we run what? 4. 1, 2, 3, 4. Put a dot right there. Now we got our 2 points. What can we do with those 2 points? Just connect them. There we go. And now we just put arrows, and there we go. That's our equation, or that's our line of the equation of a line. Okay? This is the equation of the line, this thing right here, and this is our actual line. Okay, this is our graph to that line. I know that was a lot, okay? And you guys were really good today. I really appreciate it. And so I gave you the lesson plan thing. So it's got the homework on there, but I will put it up here on YouTube. Thank you. I'll put it up on YouTube just so if you need to look at it again, you'll see it. So it's section 3.5. It's page 140. And it's 1 to 19. So there it is. That's your homework. Okay? It's the same thing that's on the lesson plan thing, but I just wanted to put it on YouTube.